Let's say you have a set of variables and you're wondering which one you should include in your model. One method to find out is to use stepwise regression. In a stepwise regression, you're trying to find the best model by adding and removing variables one at a time. Various ways exist to evaluate if a variable should be included, and here we're going to use the p-value, which is an in-sample statistic. For the p-value, the lower the better, so we are going to add variables that have a low p-value. It's an in-sample statistic because it depends only on the data we have in our current sample, and we are not evaluating the performance of the model on an outside sample. Let's go over the stepwise regression process. First, we select a maximum p-value, a threshold. Any variable that we include in the model should have a p-value below the one that we selected here. It means it has to be significant enough to be included in the model. Let's say we have 5 variables. We run 5 regressions. Each time we regress y, or dependent variable, on only one x at a time. That's why we have 5 regressions. We look at the regression results and we check if any of the xi has a p-value that's below the threshold we set at the beginning. So it has to be significant enough to be included. If we don't find any variable with a p-value below the threshold, we just stop here and say we didn't find any variable relevant enough. However, if there is at least one with a small p-value, then we add the xi with the highest r-square, so the one that has the largest power to explain the variation in y. And then we have a model with one variable xi, and we run again a regression with this xi plus another one. So if we had 5 at the beginning, we selected 1, and now we run 4 regression. Each time we have the selected x plus another one, and we try them one at a time. Then again, we look at the p-value for each of these regressions for the new variable we try to add. If at least one of them has a p-value that's small enough, then we add the xi with the lowest p-value that is not already in the model. So now we have one that was selected before, and we are selecting a second one, so we should have 2 variables. We checked with these 2 variables if any of them has a p-value that became larger than the threshold. It's possible that when we add a new variable, one of the previous variable becomes not significant. In that case, we would remove the xi with the highest p-value for the model. If we didn't find any xi that is currently in the model that has a p-value that is too high, we just don't remove any of these xi and we keep all of them. So now we have 2 variables that are selected, and we start again. We add a third variable and we try each of the variables that are left out one at a time, and we repeat until we cannot add any more variable. So once we reach a model where adding a new variable doesn't give any variable with a p-value lower than the threshold, we just stop and we have our final model. I'm going to go again over this process, but using some data. Today's data is about video game sales, and we are going to try to predict the volume of sales globally for each video game. There are 16,000 video games from 1980 to 2017, and we have some explanatory variables, including user and expert ratings from Metacritic.com. We have also some information on the developers, the publisher, and the platform, but we might not use it for this example. We only randomly selected 250 games for estimation in order to go faster and not have too many games. So here I've put the process step by step. First, we'll construct all the potential variables. We'll say which x might be entering our regression equation. Then we'll select the maximum p-value required for a variable to be included. Then we'll find the variable that has the largest r-square for y, so that explains the largest share of the variance in y, and we'll take this variable as a starting point for our model. Then we'll run a regression for each of the other variables, And if one can be included, we'll add it because it has a low p-value. If at the same time there is a variable that's already in the model that starts having a p-value that's too high, we'll remove it. And then we'll repeat for step 4 to 6 until we cannot add or remove any variable. I'm going to perform the stepwise regression process in R, but you might use other software if you're more familiar with it. I'm going to load the data, and we can see that the data has many columns. It has the video game name, the platform, the genre, the publisher, developer, rating, and the things that are more interesting for us are the global sales, which is our Y variable, the year of release, the critic score, the critic count, the user score, the user count, so how many users wrote a review, and if it's on the PlayStation platform or not. So that's PlayStation 1, 2, 3, 4, any of the PlayStations. So for this application, I've selected these variables: year of release, critic score, critic count, user score, user count, and PlayStation. I've selected a threshold for the p-value. Here it's 0.01. And so we have 1, 2, 3, 4, 5, 6 variables, so I'm performing 6 regressions. Each time I perform a regression, so here it's on year of release first, I look at the p-value and the r-square, which is here. We are looking at the multiple r-square. I wrote them here in a comment next to the regression. So for the first one, the p-value is 0.624 and the r-square is 0.1393. Then I do the same for critic score, and the p-value is extremely small, 8.74 times 10 to the power of minus 5, and the r-square is 6%. Then I have critic count, also a small p-value in the order of 10 to the power of minus 6, and the r-square is 8.5%. Then we're looking at user score, p-value of 4%, r-square of 1.5%. User count has a p-value, the smallest so far, of 6.2 times 10 to the power of minus 9. And the highest r-square so far, 12.75%. And finally, the PlayStation platform. We have a very high p-value, so not significant at all, and we have a very low r-square. So if we look at all the p-values and the r-square, we find that the lowest p-value is here, 6.2 times 10 to the power of minus 9, and the highest r-square is 12%. So we are going to select user count as a variable and add it to our model. So our base model is global sales as Y, and 1x is user count. Now we're going to run a new regression with this model, global sales on user count, and we add each of the remaining variable. So first we add year of release, and we note the p-value. Here it's 34%. Then critic score, the p-value is 0.004. Critic count, the p-value is 0.002. User score, we have a slightly higher p-value, and PlayStation, very high p-value, 92%. So if we look at all these p-values, we find that the lowest is critic count with a p-value of 0.2%. So we are going to add critic count. So now we have both user count and critic count. And I'm going to check all the p-values in this model. And we see that all the p-values are still below our threshold. No p-value is above 0.01. So we're going to keep both of them and not reject any of these variables. Then we repeat it again, but this time we start with a model with two x variables. So we have user count, we have critic count, and we add the remaining variables. So for year of release, we find a p-value of 58%. For critic score, a p-value of 3%. For user score, a p-value of 0.7%. And for PlayStation, a terrible p-value of 77%. So here, the variable with the lowest p-value is user score with 0.0076. So we're going to add user score. And if I rerun this regression, I see that none of the p-value went above 0.01, so we keep all of them. So now we have user count, critic count, and user score in our data set. We're going to add year of release and see what happens. A very high p-value. We are going to add critic score. Has a pretty low p-value now. 2.63 to the power times 10 to the power of -5. And PlayStation has a better p-value than before, but still terrible at 58%. So we add critic score, which has the lowest p-value. And if we check again this model, none of the p-value went above 0.01. We are almost above 0.01 with critic count, but we are not there yet. So we keep all the variables and we try again with the two remaining variables. Year of release has a high p-value and PlayStation still has a high p-value. So since none of the remaining variables has a p-value below 0.01, we cannot add any of these variables, and so we stop here. And the final model is the following. Global sales on user count, critic count, user score, and critic score has the following coefficients and has a multiple R² of roughly 24%. I hope that going over the stepwise regression step by step makes more clear what are the steps and why we are doing them.